Now, today we're going to go on to Law 7 of Indices. Like I said, there's 9, but we're just going to look at this one today because it's probably the most difficult one to understand and to do examples with. So in the log tables, Law 7 states that if I have a number to a fraction power, but it's not 1 over a fraction this time, so one number over another number, then the bottom number changes into the root and the top number stays as a power. We can apply the power first and then square root, or we can not square root, we can find the root first and then apply the power. So either way of doing it is fine. Now let's put some words on that because that looks really confusing. And what we say is that it's very like Law 6. So if I've got a fraction power with a number other than 1 on top in the numerator, then the denominator becomes the root and the numerator stays as a power. Let's look at some examples of that. So we're going to evaluate the following . Evaluate the following without using a calculator. So we'll just do a few examples of this. So the first one is if I had 8 to the power of 2/3, what would that be? Or if I had 81 to the power of 3/4. Okay, now, of course we can type these into our calculator and we will get the right answer, but how do we do it without using a calculator? This is one of the cases where they'd expect to see the steps of your work using the law, and you wouldn't get full marks for just writing down the answer. So what they want to see is that this is the cube root of 8 squared. So we can see the bottom number here becomes the root, and the top number here stayed as the power. Okay, so we could write this as the cube root of 64, but I don't necessarily know the cube root of 64 off the top of my head. I should, it's in our list of 5. And I said that it didn't matter whether we did the root first or the power first. So that's one way of writing it. Or I can write it as the cube root of 8 and then square my answer. So the cube root of 8, I would expect you to know at this point, it's 2 by 2 by 2. So the cube root of 8 is 2, and that's 2 squared, which is 4. So the purpose of this law is to make it easy to simplify powers like this, fraction powers. Let's do the same thing with the second one. And if you want to, if you think that you've got it, you can pause the video and try it yourself first and see if you're right. So this should be the 4th root of 81, all cubed. Okay, and I can write it the other way around as well. It doesn't matter. Usually, it's easier to do your root first and then do your power, but it doesn't matter which one you do first. So the top number becomes the power, the bottom number becomes a root. So the 4th root of 81, if you remember from your homework, is 3. And that's 3 to the power of 3, which is 27. And I would encourage you to check these in your calculator. Check this in your calculator. Now, I would like you to do some practice for the rest of today's maths class. That's the only thing I want you to take down into your notes today. Try to understand that. So I want you to try a couple yourselves now, even before you go to do the homework. Try to do this without using your calculator. 32 to the power of 3/5. So pause the video. You type it into your calculator to check your answer. And I'm going to give the solution now. So pause the video. Good. Did it work out for you? I have no way of checking, but I'm going to write down the answer anyway. So this should be the 5th root of 32, all to the power of 3. Now, if you don't know your 5th roots and things like that, you can use the calculator at this point. The 5th root of 32 is 2, because 2 to the power of 5 is 32. So you can use the calculator for this step to here, and they're never going to know. And then 2 to the power of 3 is 8. And again, if you want to use the calculator, there's no way that they can tell that you have. So if you want to use the calculator to help, but to show that you've applied the rule, that's what they're looking for. Okay, and I hope that is clear for what you need to do for the 7th law of indices. Thank you.